discussing the module 4 of the organic chemical technology course. In the lecture 1 we discuss about the soap and detergent, some of the historical development which has taken place in soap making and the changes that took place from the soap to detergent, and that was because of the availability of the raw material. In the lecture 2 of this module 4 we will be discussing about the synthetic detergent and linear alkyl benzene LAB, which is the major raw material for making of the surfactant or the detergent. Synthetic detergent industry is now one of the largest chemical industry, you can say, and the synthetic detergent that has been only possible because of the coming of the refinery and the petrochemical complexes. Synthetic detergent became popular due to lower price of the raw material, price stability and effectiveness and biodegradable nature of the new synthetic detergent like a linear alkyl benzene. In the earlier stages, because the detergent which made that was non-biodegradable nature, and so there was a problem, and so with the coming of the linear alkyl benzene, the synthetic detergent market that has increased. A detergent is a surfactant or a mixture of surfactants having cleaning properties in dilute solution. Commonly, detergent refers to alkyl benzene sulfonate, a family of the compound that are similar to soap but are less affected by hard water, because that was the problem in case of the hard water use of the soap for cleaning purposes, that was not effective in case of the hard water, but with the coming of the detergent and the process that has been improved, the cleaning process. Let us come to the, because the starting of the how we started the detergent. Earlier the material which was raw material which was used for the, that was the sodium dodecyl benzene sulfonate, because the sulfonation, even in case of the LAB we are doing this sulfonation of the linear alkyl, finally it is being used as a detergent. So, earlier detergent market was primarily from the sodium dodecyl benzene sulfonate made from benzene with propylene tetramer by Friedel-Crafts alkylation, that was there, followed by sulfonation with oleum, then the alkylation. That was the alkylation. Actually the alkylation earlier that was the HF that was being used, and now we are using the solid, that is catalyst in case of the LAB. It was found that detergent made from the highly branched structure of the propylene tetramer was not easily biodegradable. This was the actual major constraint from the environmental point of view, and later it was replaced by LAB, linear alkyl benzene, which is biodegradable nature, because we are able to take a definite carbon atom fraction in the form of the paraffin from the kerosene. Detergent, high detergency in soft and hard water, they do not react with the calcium and magnesium solution, means that is the hardness that we are having, requirement of the smaller quantity in comparison to the soap, detergency action at a low temperature, do not hydrolyze. Let us come to the historical review of the detergent industry, how the development that has taken place. Now we are seeing the whole clean and the soap market that has been captured other than the bathing purpose, which are using the by the detergent. Actually the World War I led to the development of the synthetic soap and detergent, as I told you in the lecture 1, because that was the era of the industrialization. At the same time that was required of that time, many of the petrochemicals, many of the finished product at that time that was developed, manufacture was large scale manufacture that was started. So, earlier short chain alkyl naphthalene sulfonates, and later in 1920s and 1930s long chain alcohol sulfonates that was used as a raw material for the detergent. Later long chain alkyl aryl sulfonate in 1940 that was there. During 40s and 50s, the detergent market was primarily captured by dodecyl benzene, a product formed by alkylation of benzene with the propylene tetramer in a hard detergent alkylation. So, this was the problem in case of the when we use the benzene with the propylene tetramer, that was the non-biodegradable nature. It was found that the branch structure of the alkyl group was responsible for the poor biodegradability of the detergent, because we are using detergent, and that the municipal water, the waste that was getting the that was creating problem there, and the linear alkyl benzene was introduced in the early 60s, have substantially replaced its counterparts, and the most of the detergent that is depending upon the linear alkyl benzene. Other raw materials are also there because of the again the improvement in the quality of the detergent, because of the coming of the ethoxylate. Later long chain alkyl aryl sulfonate, that was in 1940. Procter and Gamble introduced synthetic detergent in the at the Tide. Branch chain compounds in 1950s to 1960, that was the non-biodegradable nature which I told you. With the availability of the tetrapropylene benzene sulfonate replaced the soap as the key surfactant during the initial stages. Again the problem of biodegradability was there, and that was again replaced with the linear alkyl benzene. As I told you, the linear alkyl benzene sulfonate during 1960s that came to the market, and to have the, because it was the biodegradable detergent, and so that was the earlier non-biodegradable detergent was replaced with the linear alkyl benzene because of the environmental concern. And the real breakthrough in the detergent industry was due to the development of the UOP lab process and availability of lab from the petrochemical company. Where the UOP they developed the Molex process for the separation of the paraffin from the kerosene, and even the whole process of the LAB that was developed by the UOP. It was the actually even in case of the UOP process, there was a lot of the development that earlier they started the alkylation using the hydrofluoric acid, and then it was replaced with the solid acid. Ability of the paraffins from the kerosene fractionation and for olefin and benzene from the refinery and petrochemical company led to the large scale development of the synthetic detergent industry. This was the how the development in case of the synthetic detergent industry that took place. Major breakthrough, as I told you, in case of the LAB has been development of the environmentally friendly solid acid catalyst, which replaced the conventional old hydrofluoric acid catalyst, because normally in the case of the alkylation process, first we started with the sulfuric acid and then it was the hydrofluoric acid, and again the problem in case of the hydrofluoric acid was there, more actually the requirement of the acid was there in case of the sulfuric acid, but in case of the HF, because it is highly corrosive in nature, so again the people started searching the alternative for this, and so that was the development of the solid acid catalyst for the alkylation part, which we will be discussing in detail in the next few slides. This is the various type of the detergent and the various name. It may be wheel, Ariel, sulfur, the surf, Nirma, number of the it may be the powder form, liquid detergent that may be available. So, this is the how the detergent industry is growing because of the more and more uses of the detergent, and that is the driving force for that is the one driving force is your its consumption, rise in the population, second is the availability of the raw material, the development in the technology of the separation process, which has led to the lot of the economical production of the LAB. These are the application of the LAB in India at the various stages, not only for the fabric, but other uses are also there. And so these are the consumer and application. Consumer cleaning products, synthetic detergent for fabric wash, popular, mid price, premium, scoring products, liquid detergent, industrial and institutional cleaners, other industrial application, non-surfactant application just like in varnish, cable fluid oil, lubricant, some of the detergent that we are using. So, this is the how they and the percentage share. You see the percentage share of the application that is there, 96% that we are higher percentage in the case of your. So, classification of the detergent, you see the detergent that has been classified in different way. So, one classification is anionic, negative charge, used in the laundry and the hand dishwashing. Long hydrophobic alkyl chain is the anionic part. This is about the anionic. We are having the anionic, cationic, non-anionic, amphoteric. So, in case of the cationic, positive charge used in the fabric softeners and the fabric softening in laundry. Non-anionic, no charge, low stirring, used in as dishwasher, detergents and rinse aids. Amphoteric, either positive or negative charge that may be there, used in the personal cleansing and household cleaning product. Ethoxylate, now that has come in a big way from the ethylene glycol, the ethylene oxide, because now this ethylene oxide that is being produced from all the cracker plant, we are getting ethylene and the ethylene oxide, and then the ethoxylate that has become a very important product. Major application, these are the already we have discussed about the even the shampoo formulation also we are using the so laundry detergent, textile fabric, fabric softener, household kitchenware washing, soapless soap, shampoo formulation. Again these are the some of the various type of the specialty surfactant that is available in the market, that the anionic, amphoteric, cationic and non-ionic. Here the alkyl polyglucosides, amino oxides. In some of the cases the some nitrogen compounds are also there. Here ether carboxylates, acrylothionates, phosphate esters. So, these are the some of the coming in case of the anionic detergent. Anionic detergent, let us now come to the typical anionic detergents are alkyl benzene sulfonates. The alkyl benzene portion of these anion is the lipophilic and the sulfonate is the hydrophilic. Two varieties have been popularized, those with the branch alkyl group and those with the linear alkyl group, because in case of linear group definitely is more biodegradable nature. Cationic detergents are similar to the anionic ones with a hydrophobic component, but instead of anionic sulfonate, the cationic sulfonates have quaternary ammonium as the polar end. The ammonium center is the positively charged. So, this is about the cationic detergent. Ethoxylates are compounds that have long hydrocarbon chain, but terminate with this group. These groups are not charged, but they are highly hydrophilic owing to the presence of many oxygen centers. Non-ionic detergent, these are characterized by their net uncharged hydrophilic head groups. They are based on the polyoxyethylene glycol. These are the some of the various varieties that are available. Now, what are the various component of the because the basic raw material is the your detergent part. So, along with the detergent, in case of the various formulation, we are adding other materials also to improve the detergency, to improve the cleaning efficiency and to sometimes reduce the cost also. So, builders for foam, because foam is also very important, filler and processing aids, anti-deposition agents, fabric brighteners are also being used, corrosion inhibitors are there, antimicrobial agents are there. Now the enzymes, because the enzymes are also being added, and this is what the different type of the grades of the your detergents are available in the market. They are claiming that the better cleaning is there, and this is the premium detergent, like that. So then the bluing, because normally you must have seen the detergent slightly bluish form is there. Basic component of the detergent, you see the detergent, that is the base is the linear alkyl benzene sulfonate, because most of the detergent, all the detergent, they are now using the linear alkyl benzene sulfonate. Builders phosphate, sodium triphosphate, and both detergent powder, citrates, silicates, carbonates, zeolite, these are the builders. Filters and processing aids, sodium carbonate, sodium sulfonate, that we are using. Corrosion inhibitors, that is also added, there is sodium silicate, anti-redeposition CMC, carboxymethyl cellulose, that we are, fabric brighteners, fluorescent dyes, that we are using in case of the fabric brighteners. Antimicrobial agents, that is the carbonylites and the salicylate, enzymes decompose or alter the composition of the soil and render the particles more easily removable. So that helping in the cleaning. So that is why enzymes are also there. Bluing improve the whiteness by counteracting the natural yellowing tendency. Now let us come to the linear alkyl benzene, because this is the major raw material we are making in India also. The linear alkyl benzene is the basic raw material for production of the most widely used detergent, linear alkyl benzene sulfonate. Linear alkyl benzene sulfonate was introduced as substitute for non-biodegradable branch alkyl benzene. LAB is a clear colorless liquid with the characteristic odor. So already I discussed about the importance of the linear alkyl benzene, which is the basic raw material, and normally, because you see the biodegradability of the linear alkyl benzene is very important factor, and so for getting the biodegradable nature, what we need is the specific carbon atom in the raw material that is needed. So the linear alkyl benzene produced from the C10 to C13 or C11 to C14. So linear mono olefins are used, because if you are increasing the carbon number, if it is more than this, then the non-biodegradable nature of the your linear alkyl benzene will be produced. So this actually after getting the linear alkyl benzene, this is sulfonated with the linear alkyl benzene sulfonate, which is actually the basic detergent that we are using. Earlier also I discussed about the LAB, which is it was introduced into it came into the market in 60 as substitute for the non-biodegradable. Other surfactants are also there, that is getting importance, that the alcohol sulfate, alcohol ethoxylates, which I was telling about the ethoxylate, secondly alkane sulfonate and alpha olefin sulfonate. These are also being used in the detergent industry, because these are some of the alternative raw materials also. These compounds constitute the active ingredient of many household detergent, that is the LAB. They are surface active compounds which are combined with the various builders of an inorganic salt to make a detergent formula, that is the final detergent which are getting. Although the LAB demand grew by 14% per annum during 1984 to 90, future demand in the country is projected to increase at a healthy growth rate of 7 to 8% as against 2 to 4% worldwide. Because India and China, they are having huge population. The largest market for LAB is in these two countries. So for production of the LAB in India is concerned, we started manufacturing LAB in 1985. That was the first plant by the IPCL, and it was followed by Reliance Industry at Patal Ganga. Reliance was the first plant. IPCL now it is taken over by the Reliance Industry at Vadodara. That was the first plant, and you see the IPCL at that time when it was started, that was a large petrochemical complex which was manufacturing a number of the petrochemicals. So here they were having the catalytic reforming for getting the benzene, and so that benzene that was being used here. Then the paraffins which was used for the making the olefin, that was actually produced by the fractionation of the kerosene. So these are the some of the units which are manufacturing, that is the IPCL, now the Reliance Industry, Tamil Nadu, Reliance, the Patal Ganga, Tamil Nadu Petro Products, Nirma, and new plant which came later, that was the Indian Oil Corporation. They have started their plant at Vadodara unit, and that unit is based on the solid acid catalyst, because earlier other units they are using the hydrofluoric acid, but Indian Oil Corporation they started their UP LAB plant based on the solid acid catalyst. Now let us go to the detail of the LAB process. So first step in case of the LAB manufacture is the pre-fractionation, because the pre-fractionation means the here we need the paraffins for the changing to the for making the your olefin. So to obtain the C10 C14 range hydrocarbon from kerosene we are taking, so that will be the, in case if the carbon atom for light LAB and if the carbon atom is high then the heavy LAB. So these two grades are there. Hydrotreater, because always the raw material which are using that may contain some sulfur compound, and removal of the sulfur compound, that is very important, and so that has to be removed before it is going to the paraffin separation, just because it will poison the catalyst and the adsorbent also in the subsequent stages. So that is the important of the hydrotreating to remove the sulfur. Paraffin separation, to remove the N paraffins from kerosene by selective adsorption using molecular sieve, and this process we call it the Molex process, that has been developed by UP. Then dehydrogenation of the paraffins to olefins, that is the PACAL process we call it, the in case the UP process they have named it the PACAL process. So dehydrogenation of normal paraffins to olefins. The next step is the alkylation of benzene with olefins to obtain LAB in presence of HF or the solid acid catalyst. Now let us go in more detail about the process to obtain the C10 C14 range hydrocarbons from the kerosene, because the kerosene that is one of the major raw material for making of the LAB, and that we are getting because kerosene that contains higher or the lower paraffins also, and so those paraffins has to be removed. Only what we need in case of the LAB, that is C10 to C14 carbon atom paraffins that we are in. So the LAB requires a very specific feed in terms of the carbon number. The pre-fractionation unit is designed to process a high purity C9 to C15 linear normal paraffins feed and to separate out a hard cut with the desired carbon number, which will range from the C10 to C13 for light LAB and C11 to C14 for heavy LAB. So pre-fractionation and the to get a particular cut that we are having during the pre-fractionation stage, and rest of the kerosene which we are getting, that will be again recycled to the system. Hydrotreater, as I told you, this is important for removal of the sulfur compounds from the stock. The purpose of this unit is to remove sulfur and nitrogen from the feed without greatly changing its boiling point. If not removed, sulfur and nitrogen would poison the sieve in the Molex unit, that adsorbent we are using in the Molex process. Then the next step is the paraffin separation. Here the continuous separation that is taking place, and this process, Molex process, is based on the adsorption. To remove the normal paraffins from the kerosene by selective adsorption using molecular sieve, the UP Molex process is an effective method of continuously separating normal paraffins from a stream of co-boiling hydrocarbon by means of physical selective adsorption process. And so to get a definite fraction of the kerosene as a paraffin, because we need, as I told you, we need the C10 to C14. The feedstock is separated into a high purity normal paraffin fraction at high recoveries and a non-normal paraffin, because the other fraction that has. So this is the selective adsorption of the normal paraffin by the Molex adsorbent. So this is very important to get the high purity product. This is the pre-treatment and the paraffin separation process that is taking place. You see this is the kerosene pre-fractionation column, then the steeper overhead, again filtered to solvent recovery. This is going to the, this is not part of this, this is coming in the other. So pre-fractionation column, and then the finally the return bottom to the heavy paraffins that will be returned to this, that will be used as a fuel again, and so it will go to the heater, hydrogenation reactor. Hydro treatment means the pre-treatment of the paraffins which we are separating from the fractionation column, and so after the hydrogenation means that is the desulfurization process, removal of the sulfur and nitrogen compound, and then it will go to the Molex unit. Molex unit means the raffinate and the extract phase that will be there, and so the adsorbent means that we are getting here, and that the finally it will go to the Pacal unit where the that will be, because here you are getting the paraffin. So paraffin separation is taking place and the paraffin separation, that the, and here in case of the Molex process, that continuous regeneration of the adsorbent is there, and that adsorbent again continuously that is being done, and the separation is very efficient in case of the Molex process. So that was the real breakthrough also, you can say, in case of the LFB, because the development of the some of the adsorbent, and especially because the UP has been the pioneer. They have developed a number of the adsorbent. One is the Olex, and the Pyrex, which is being used for the Olex for the olefin separation, Pyrex is for the paraxylene separation, and here it is the Molex for the separation of the paraffin. So finally the this Molex unit, from the Molex unit paraffin, that will go to the Pacal unit, and then from the pattern the olefin that will go to the alkylation section. Let us come to the, because the next step after the separation of the required carbon number of the paraffins, the next step in LFB manufacture is to have the dehydrogenation of the paraffins to get the olefin. This process dehydrogenates the high purity linear paraffin feedstock from the pre-fractionation unit into corresponding monoolefins suitable as feedstock for the alkylation purpose, means downstream detergent alkylation unit. Some of the actually the catalyst poisoning, because we are having the different type of the catalyst poisons. One is the temporary and the permanent. Temporary means that can be removed by some treatment, and this is the reason why we are having the pre-treatment of the feed which is going to the Molex process. So sulfur, excessive amount of sulfur in the liquid feed will attenuate the metal function, and accordingly higher operating temperature have to wait. It will reduce the catalyst life also. Then the other impurities which may be present, because you see the sulfur compound, nitrogen compound, inherently present in the raw material, and so it will readily form ammonia and can react with the chlorides to form the ammonium chloride salt. Again it will poison the catalyst. Oxygenates most would react to form water, low levels are not a problem. Now let us come to the alkylation process. The alkylation of the benzene with the olefins to obtain LAB in the presence of HF or the solid zeolite catalyst, that we are what we call it the acid catalyst. This process alkylates benzene with a linear olefins produced by the Pacol process, because in the Pacol process what we are getting, in the Pacol process we are converting the paraffins to olefins, and these olefins that we are using here for alkylating the benzene. Again the benzene, you see the benzene that we are getting from the catalytic reforming process, the reformant which you are getting for the, because the catalytic reforming, that is the integral part of any refinery and the petrochemical, because depending upon the requirement, if you are going for the improving the octane number and the you are interested in the gasoline, so simply the reformant that will go to the gasoline. If you are interested for the getting the recovery of the benzene, toluene or the xylene, then the reformate from the catalytic reforming, that will go for the separation of the benzene, toluene and xylene. And as you know, the separation of the benzene or the use of the benzene, that is very important for the polyester manufacture, where we are making the terephthalic acid. But benzene separation, because the first amongst the all the aromatics means the benzene, toluene and xylene, benzene is having the lower boiling point, and so the benzene is separated from the reformant which you are getting after the catalytic reforming, and so that benzene that is available from the refinery. And this is the reason why some of the refinery, although they do not have the TPA plant, terephthalic acid plant or the DMT plant, still they are separating benzene, because that benzene that is being used in the your LAB manufacture, or it may be other application, just like you take the case of the manufacture of the caprolactam, where the we need the your raw material, and so from the benzene to caprolactam that we are using as raw material. So this is how the benzene we are getting. So alkylation of benzene with the olefins to obtain LAB in the presence of hydrofluoric acid and solid acid catalyst. This is the process that we are using in the alkylation. This process alkylates benzene with the linear olefins produced by the Pacol unit in the presence of HF acid catalyst to yield the linear alkyl benzene. So the next, in case of the LAB, thus produced can be readily sulfonated to form a suitable ingredient for many household detergents. This unit consists of alkylation, because the product of the alkylation that we are getting, alkylation section, fractionation section, acid regeneration section, because the acid recovery, that is very important if you are using the hydrofluoric acid, and still many of the units they are using the hydrofluoric acid. So acid regeneration, that is very important. But in case of this solid acid catalyst, again the regeneration of the catalyst is there. But here the your effluent, the environmental, from the environmental point of view, this process HF alkylation process is not desirable. So that is the reason why it led to the solid acid catalyst. This is the alkylation unit. It may be the benzene, and then the input that is here, it is not shown, but the your olefins from the Pacol process that will come to the alkylation unit. HF is catalyst, then the steeper light end columns, which is paraffin columns, where some of the paraffins that may be there which is removed, and then finally it will go to the LAB column. and where the linear alkyl benzene that will be given, and heavy alkylate that may be there, and so that has removed. Now I discuss about the why the shifting from the hydrofluoric acid catalyst to the solid acid, because this has been a major development in case of the alkylation process. Even in the refinery where we are using the alkylation process for getting more high octane number. So alkylation process there also and now solid acid catalyst that is being used. So HF acid has been the principal catalyst for the production of LAB from the linear olefins, and most of the plants before coming of the Indian oil plant at Vadodara in India, all the plants they are based on the HPC, hydrofluoric acid. How about the handling of the corrosive catalysts such as hydrofluoric acid have always some disadvantages. I told you the corrosiveness and from the environmental. Highly corrosive environment is there because of the hydrofluoric acid, and that will result in the higher equipment capital cost in case of the hydrofluoric acid. Disposal of the small quantity of the neutralization product generated by the process, that is also creating some environmental problem, and so these are some of the disadvantages which we are having because of the use of the hydrofluoric acid as catalyst. This is the complete actually the process that we are using in case of the any LAB plant. Here the kerosene and this particular fraction of the kerosene, because the kerosene that is in between the naphtha and the diesel part, and so the boiling point may be in the some of the 140 means naphtha range, also in the around 210. So kerosene with this fraction, and then it will go for the fractionation, so that you are getting a particular cut of the kerosene, that will be the, and here rest of it is written already, I discussed this diagram. So again it will go to the after the separation in the pre-fractionation, it will go to the hydrogenation, where we are doing the hydrodesulfation, remove the other impurities also, and then it will go to the Paccal unit to the alkylation unit, where we are adding the HF catalyst. Here it is the olefins which we are getting after the hydro treatment also, and so because hydro treatment initially before going to the Paccal, we are removing all your impurities which are present as sulfur compound or with nitrogen. So hydrofluoric acid, that we are, this is actually in case when you are using the hydrofluoric acid, slightly some changes are there in case of the flow diagram when you are using the solid acid, and this benzene, as I told, this benzene we are getting from the catalytic reformer. Then you see to the stripper, and then the HF hydrofluoric acid, that will be the regeneration, and the light end columns where some of the unreacted paraffins that may remain. So and the benzene, that will be again separated, and that will be reused, and this paraffin again it will go to this, and finally we are getting the next step actually in case of your making of the final detergent. This is the steps involved. We are using the oleum for sulfonation of the linear alkyl benzene, then it will go to mixture where adding the various ingredient, neutralization, and then finally here it is the neutralization part, and finally because the traces of the acid that will be not desirable. So finally in the mixture we are adding the various additives, phosphates, enzymes, all the things, and then the linear alkyl benzene sulfonates, that will be available from the process. This is the reaction that is taking place in case of the Paccal process. Now the next step, as I told you, in case of the after making of the linear alkyl benzene, this is the sulfonation of the linear alkyl benzene. This involves using sulfuric acid to produce linear alkyl benzene sulfonate, which is the main ingredient of the detergent. This is the process which I discussed earlier, the linear alkyl benzene sulfate, where you are doing the sulfonation, mixture, neutralization, and then silicate, phosphate as a builder, and other ingredients of the surfactant that you are, and the final you will be getting the LFB. Again, the final formulation of the detergent which you are getting the finished product, because this is the basic raw material that is being supplied by the LFB manufacturing. Either they can, because again here you see that may be the, in case of the plant, it may be only the LFB that is available from the major producer. They will provide the LFB. Rest of the process, sulfonation, mixing of the base ingredient, mixing of the fillers sometimes, because if they want to reduce the cost, they are adding the fillers also. All those activity that is taking place at the formulation stage, where they are making the final surfactant, a final detergent, and the quality, because the cost of the detergent, because this surf, you take this surf, various grades of the surf are available in the market, and they are claiming better and better cleaning efficiency with the, and the cost is also increasing with the different grade. So, the addition of the various ingredient, that will depend upon the quality of the your raw material. So, that was the actually about the, I was telling about the formulation part, that is the part of the final making of the detergent, bars, soaps, flakes, all those things, that will be the, that the plants separately that is being done, because these major producers, they are supplying the linear alkyl. Now, let us come to the solid acid catalyst, and this is the real breakthrough in case of the alkylation process, whether it is in case of the LFB manufacture or in case of the refinery, because the conventional catalyst we use the aluminum chloride, and then it was the H2SO4, and from the H2SO4 and HF, because the HF was considered found better catalyst for alkylation than H2SO4. Amount of the H2SO4, that was about more than, it was around 3 to 4 times more than the what we are using, and so that was the reason why it was, and the even the quality. So, we shifted from H2SO4 to HF for alkylation, and so this was the some of the disadvantage which I discussed earlier also, causing corrosion of the equipment as well as the waste production. There has been continuous search for development of non-corrosive solid acid catalyst with the similar catalytic property, and so this was the how the UP they were able to develop the solid acid catalyst for manufacture of the linear alkyl benzene. Some of the catalysts which have been developed are SiO2 L2O3 combination, H antomoltrine, ambrylized, HY, H beta, HM. World lab capacity was around 3 million tons, with nearly 85% you can say the based on the HF alkylation. Only 5% on the aluminum kind, 10% on the newly developed fixed bed. But in the future, because the environmental from the environment point of view, things are becoming more and more stringent standards are there. So, now the people definitely they will have to shift from the HF catalyst to solid acid catalyst, but only thing that the cost, definitely the cost of the solid acid catalyst, that is higher than the what we are using in case of the HF catalyst. So, that is also, but that may be one of the constant for shifting from the HF catalyst to solid acid catalyst, but you cannot go on compromising with the environment. So, they will have to shift from the HF to solid acid catalyst. The fixed bed alkylation was first introduced on commercial scale in 1995 by Canada, and this is the actually the fixed bed technology based on the solid acid catalyst, we are having at the IOC, Indian Oil Corporation Vadodara unit, which started manufacturing. It was around 2005. Because the Indian oil, they have come in big way in the making of the petrochemical. They are just integrated their refinery with the petrochemical, and in that actually step they started manufacturing LFB at the IOC Vadodara, and then the TPA, terephthalic acid, at the Panipat refinery, and in the now the Panipat refinery, that is one of the big hub for the petrochemical, that is petroleum and petrochemical hub of the northern part of India. So, this is the how the development that has taken place, and the new plants which are, if it is coming, definitely that will be based on the solid waste category. Here also the most of the processes which are involved in case of the HF catalyst up to the olefin production, that is same, except the alkylation stage, where we will be doing the alkylation not in presence of the HF catalyst, but it will be on the presence of solid acid. So, here again, as in the case of the HF catalyst, the process which we discussed, kerosene feed hydrotreating after the fractionation, because here this is only the simplified flow diagram is there. We will have to fractionate the kerosene, you will have to get the paraffin of the required carbon atom, and then it will go for the hydrotreating for the removal of the catalyst poison, or the which may poison the here in case of the your paraffin separation, the molecular shift which are using. So, that has to be removed during the hydrotreatment process, and then after that it will go to the molecular shift selective separation, which was there in case of the process which we discussed earlier, and then the catalytic dehydrogenation, again this is the converting the paraffins to the olefins. And because here we will be getting again the olefins of the higher carbon, not higher means desired carbon atom, which will be the of the because the olefin, the alkylate which will be getting of the alkylation of the benzene and olefin, that will be of desired carbon, because just to have the more and more biodegradable nature. So, this is the selective hydrogenation, aromatic extraction, the molecular shifts, and finally the fixed bed alkylation unit, where we are using the acid case, and finally we are getting the linear alkyl. So, this is the process that is being used, and so in future all the LAB plant that will be based on the solid acid catalyst. Now, you see we are also having the powder detergent, the solid and liquid raw ingredient dropped into a large tank known as the slurry mixture, and as the ingredients are added, the mixture heats up. As a result of the two exothermic reactions, the hydration of the sodium triphosphate and the reaction between caustic soda and the alkyl benzene sulfonic acid. The liquid detergent contains soap as well as the they are actually the spraying. The spraying process is also there for making the your detergent, and liquid detergent contains soap as well as synthetic surfactant. This is usually made first as a premix, then other ingredients are blended into it. This step simply consists of neutralizing fatty acid rather than fats themselves with either caustic soda or the potassium acid. So, in the market you see the detergent, powder detergent, even the size of the granules which you are getting, even you see the detergent manufacture, the final detergent product, lot of the manipulation part is also there, just to increase the weight of the. So, if you see the surf, its bulk density will be lower. In some of the detergent, the bulk density, because they are adding more sodium carbonate or sodium silicate, so the cost that will reduce, and but the detergency power definitely that will be in case of the less and less fillers also. So, this is the about the LAB plant and the manufacture of detergent, and so the, because as you see the more and more detergent plants are coming, so the future detergent plant, that will be definitely on the solid acid catalyst, not on the HF catalyst. And the one of the major reason for the growth of the detergent industry has been the availability of the raw material, whether it is the paraffin from the kerosene or benzene from the refinery or the petrochemical complex. That is the one of the driving force along with the population for the development of the detergent industry, and at the same time we have been able to reduce the cost of the detergent, because with the availability, with the production, mass production of the liquid of the LAB, and as I told you, we are having 5 major units which are producing linear alkyl benzene. So this is the how the development and that is taking place, and the driving force, and the why the cost factor, because that is has been very important, and that was the one of the reason also from the soap to detergent.